everybody. Welcome to this lesson, which is on graphs and tables for univariate data. I'll mention that univariate data is data where you're looking at just one variable at a time. In this video, I'm going to go over the concepts, what kind of graphs go with what kind of data, and then how to interpret those. I'm not going to show you in this video how to create them in Excel. I'm going to do a separate video for that. So for all of the graphs in this section, we're looking at the distribution. The distribution is any way that you show all of the possible values of a variable, what those possible values are, and then how often they occur. You can do that in a table, or you can do it in a graph or plot. You can do that for a sample or a population as well. All the ones we're looking at in this lesson are for a sample. We'll look more at the population when we get to the probability section. All right, so distributions look different based on the level of measurement that they are. So if you're rusty on your levels of measurement, you might want to go back and review or talk to me and I'll be glad to go over that with you. So looking first at qualitative data, and that's data that's categorical. The first thing we're going to look at is a frequency table. A frequency table just lists all the values in your data set and then their frequency, meaning the count. So I made up this data set where you assume you've got a restaurant and they keep track over, say, one day of the restaurant, what sides people order. And they have 4 options: fries, corn on the cob, coleslaw, and green beans. And so they just keep track of how popular each one of those are. And they've got, in that one day, 42 customers. This says 43 here, but keep in mind the first row was a label. And so we just make this table that lists all of these possible values, and we count that there are 11 people who ordered coleslaw, 12 who ordered corn on the cob, 10 who ordered fries, and 9 who ordered green beans. This is the frequency. Okay, so you could call this the frequency table, the frequency distribution, the frequency distribution table. As long as you know those terms, you're fine. All right, so these are the frequencies. If we want to see the relative frequencies, that's just the percentages of the total. So we have 42 customers, so 11 out of 42 would be 26.2%. 12 out of 42 is 28.6%. So that's what the relative frequencies are. So those are the charts. For the graphs, we might want to see a bar chart, which seems strange to me they call it a chart, even though according to our terminology, that's a graph. Anyway, so a bar chart is just another way of showing that frequency table or the relative frequency table. So you've got all 4 possibilities down here on the x-axis, and then you've got either the frequencies or the relative frequencies on the y-axis. And it doesn't matter, the bars are the same height regardless. It's just a matter of, how these are labeled. And then the pie chart as well. The pie chart probably would have looked a lot better if we'd done the relative frequencies rather than just the frequencies. I just think pie charts look better when they're labeled, as a percent of 100 out of 100%. But But regardless, what you're looking for here, and there's not a whole lot you can say about one of these graphs, one of these tables. It's just, what's most common. It looked like corn on the cob was the most popular, followed by coleslaw, followed by fries. Green beans are the least popular. But if you look at all four of them, there wasn't one that was, even green beans were fairly popular compared to corn on the cob. So it's not like you can see one that they ought to just take off their menu because nobody's ordering it. All right, so for qualitative data, again, we're looking at the relative frequency table and the bar chart. I'll put in here or pie chart. I don't love pie charts, but. All right. So that's qualitative data. Now for quantitative data. Now quantitative data, we're actually going to divide a little further because quantitative data might look a little different based on how many possible values there are of the variable. We're first going to look at one where there's not a lot of possible values of the variable. In this first one, we're looking at a store and how many staff they had on duty on a given day. So they kept track for 36 days, so a little over a month. They kept track of how many staff members they had in the store. And so just the same way we did before, we make a relative frequency distribution. With the qualitative data, it doesn't matter what order you put these things on there. These happen to be in alphabetical order because that's the way Excel did them when I did it in Excel, but they can be in any order. Here it does matter. Here you need to put these in increasing order. Obviously, I think nobody would make a table like this with these not in the right order. And then just like before, you list the frequencies and you come up with a relative frequency. So this would be 2 out of, I think we said we had 36 data points, so 2 out of 36, 7 out of 36, etc. Now, this is a bar chart, but when it's a bar chart of numeric data, they call it a histogram. All right, so it's a histogram because this variable here is quantitative. And I made this a histogram based on the relative frequencies. And you can see here that it looks like most of the time, or more often than not, there were 6 people in the store, followed by 3 and 4, and then 5 and then 7, and then there were only a couple days where there were 2. It's possible to look at a cumulative distribution as well. There might be some times when somebody would want to look at that. A cumulative distribution just tells you, so these first 3 columns were just our frequency distribution, relative frequency. The cumulative frequency tells you the frequency of each row of data or less than that. So if we take, say, this 4 here, this means that there were 16 observations that were 4 or less. This 22 means that there were 22 times that there were 5 or, I shouldn't say less, 5 or fewer people in the store. And the 31 means that there were 31 times that there were 6 or fewer people in the store. And then the cumulative relative frequency is just like with the relative frequencies. It's 2 out of 36, 9 out of 36, 16 out of 36, etc. All right, so that's quantitative data where there aren't very many possible values of the variable. And what I mean by that is there's few enough that you can just list them. You may end up, though, with data where there's too many of them to list. And let me show you an example of that. So if we look at this data here, there's so many possible values. Hardly any of them, if any, are going to repeat. So here we've got 28 data points, and probably all 28 of them are a different value. So if we did the same way we did before, we'd end up with a table where each value had a frequency of 1, and there were 28 different values. So instead, what we do is we group them. And we group them into categories. So this one is categories of width 500, and it's width 500 because they go 500 to 1,000, starting at 500. So 500 is the first category. All right, and the way these are constructed, you see this is a round bracket here. This is parentheses on the left. That means that the interval does not include 500, and the square bracket means it does include 1,000. And then we have our frequencies and our relative frequencies, just the same way we did before. I'll point out here that there were no observations in this category, but even so, we want to leave a blank for it, okay? Because the whole point here is to see where things are laid out, and if there's a gap, we want to see that. I'm not sure I mentioned this was sales. This was the amount of sales in some business on a given day, and we've got 28 days of sales. We could look at a cumulative distribution just like we did before, where we see that we've got 16 observations that are up to 1,500. We've got 26 observations that are up to 2,000, etc. But what's really important here is the histogram. One thing that's different about these histograms where the data is grouped is that the bars need to touch. So you do need to generate those histograms so that the bars touch. The reason is that you've got data that goes from 500 up to 1,000, and so this 999 observation over here needs to be right next to 1,000. Ideally, we'd have these labeled a little differently. We'd have this labeled as 500, this labeled as 1,000, this labeled as 1,500, etc. Now, one thing you need to be aware of, and this is important, is that different histograms have different shapes. So you see this one, it increases and it decreases. And I don't mean that this is happening over time. When I say it increases and decreases, what I mean is that most of the values here in the data set are low. There are only a couple that are high. Most of the data is down between 1,000, and 2,000. So there are different sort of general shapes that histograms will fall into. Uniform is if all of the categories are about the same height. And when I say categories, I mean your numeric data, because there's no such thing as a distribution shape for qualitative data, only for quantitative. So if all of the values here are equally likely, you might have a uniform distribution. An example of that, you'd be likely to see that if you were rolling a die over and over again, a fair die. You'd probably see 1s and 2s and 3s all about the same frequency. Bell-shaped is if the data looks like a bell curve or a normal distribution. So it's symmetric, where you've got a mound in the middle. Bimodal is data where you've got two humps, two places where there are a lot of common values. They don't have to be the same height. When we look at incomes, those are almost always going to be skewed to the right, because there's just a few people with high incomes, but most people have, on the low side. An example of something that's left skewed would be scores on an easy test. So if the test is easy, most people are going to do really well on it. There's going to be the high scores, and then there's just a few people down on the bottom. The thing with these is, though, that a lot of times histograms don't fit neatly into one of these categories. If we look at the ones we just did, this histogram, I guess as much as anything, it's skewed to the left. You could say it's bimodal, but then that's really just because of this one category. So it really doesn't have a good shape in terms of one of those. But if I were to ask you for the shape, as long as you gave me something reasonable, that would be fine. Skewed to the left would be all right. I would say that. I would accept bimodal as well. This one here, I would say is skewed to the right. Even though this is just 2 data points here, still it's skewed to the right. Let's look at some other ones, though. What about this one here? I would say this one is also skewed to the right. I mean, it's not perfect, but it looks skewed to the right to me. This one is almost a perfect bell shape. If this bar here were a little bit higher, except for this bar, it's almost a perfect bell shape. So I would say that one's bell-shaped. What about this one here? This one here, this is a trick question. This is not a histogram. This is a time series graph. So with a histogram, we are not looking at something that happens over time. We're not saying the values went up and then they came back down. Here we are. This is actually a plot of coronavirus cases, new coronavirus cases that I got from the Washington Post back in September. This is actually looking at the number of cases which went up and then kind of leveled off, maybe went down just a little, and then went up a little bit, and then came down a little. This does not have a shape. Okay. I put this in here because I wanted to point out that time series graphs are not histograms. And this one, also a trick question. Not a histogram. Qualitative data does not have a shape. Okay. All right, so that's it for this video, and stay tuned, and in the next video I'll show you how to create these in Excel.